Hi all. Today we'll talk about Git branching. First we will understand what a branch in Git is and how to create it and why do we even need it. Okay. And we all know Git works by taking the snapshots. It doesn't take the differences. Like to know what is the snapshot on how it works, you refer to my initial videos. And in a Git, what we are doing is whenever you make a change, you commit it. So basically, whenever you are seeing a new version of the code, you are basically creating a new commit. So creating a new commit is creating a new version, because even in previous videos what we have done, we made changes, we stage it, and then we commit it. So each commit refers to a new snapshot. So basically what happens is the commit represents the version here, and we see how the commit object looks like even we saw, right, whenever we make a change, like commit represents who had committed it, at what time they have committed it, what is the commit message, and what all changes we have done. We can see everything in a commit. So in Git, how Git objects looks like is, like here if you see, first you have a overview of the commit object. Like whenever you create a commit, it will it will generate a hash key for that. Like commit will have a hash key because it should have some key, right? Otherwise how will we identify it? Like a person has a name, even commit also has its hash key. Using that we will identify the hash key. So like overview commit, it will have its hash key, and then it will have who has committed it, like author, and when, like who was the author of the file, and who was the author of the commit, who has committed it, and then what is the initial commit message. So if you see here, this is the commit message actually. Okay, so it will have overview all these changes, like message, author, and then commit, and then the person who has committed it. Along with that, we will record the changes also, right? Like now I have edited a file, I have added two new lines to that commit, right? Then what happens when I add two lines, it should show the differences also. So how it records the changes, it will collect a tree. Okay, if you see here, initially you have the commit, author, committer, and here you have a tree as well. So it points to the tree. So what tree says is, it will have the changes that had happened in that commit, like a list of files. Basically it will get records the changes as a blob. Okay, so what it will record is whatever the changes that we have made to the files, it will represent in the form of a tree. Here you have a tree, right? This is a tree. Okay, and in the children it will have each file changes. Let's say I make changes to A, B, C. Okay, here what it will do is, it will create a file containing file names like A, B, C, and it will contain pointers to the changes, to the changes. So how it happens is, initially you will have a commit object where it will have the author, committer, and all, and then it will point to the changes, and each file change will be pointing to the like here you'll have the file name set, and each file will be pointing to the set of changes. The same thing you can see here. This is how a commit object looks in a Git. Whenever you make a change, create a commit, and the commit object looks like here, looks like this. Now you keep committing things to Git, right? So in that case, what happens is, initially when you have created a project, this is the first time you're creating a commit. Okay, and you like commit is nothing but snapshot actually. So when, like for the very first time when you are making a commit, what it has, it will have the tree will point to the file changes. Initially it will have the list of file names, and each file will be pointing to the individual file changes. Here Git stores it as a blob. Okay, and it will have the author, committer, and the commit message. Along with that, you will have a parent object as well, because I'll explain why it will have this parent object. But for the first time when you're committing it, your parent will be null. Okay, now I'm making a second commit, and when I'm making the second commit, it will have the commit name, commit hash key, it will have the author, committer, and it will have the commit message. Along with that, it will have a tree which will contain the changes as well, which will point to the list of file changes. Along with that, this is the second commit of your project. So what it will do is, it will have a parent object which will point to the first commit. Okay, which will point to the first commit. So here parent will have, parent value will not be blank, it will point to the first commit. When you are making the first commit, this is the first commit, right? You don't have any previous commits. That's why your parent is null. Here you have a previous commit, that's why your parent object is populated. Here if you see 986 CA9 is the commit ID of this commit. The same ID you have like it you have here. And likewise, when you're making a third commit, here also it will have the commit hash key, and it will have the author, committer, and this is the commit message. Okay, and it will have the parent would be the previous commit. So here this 34AC2 is the commit ID, and here you have the same thing. It will point, it will have a pointer to the previous commit. So these are the snapshots actually. This is how a Git project looks. Basically it has the commits, and like if you get the latest commit, what you can see is you can navigate to the previous commits and you will see what all the changes that happens in a Git. Now coming to the Git branches, what happens is, let's say initially a single branch is present on Git. Okay, now by default currently based on the Git version, currently the default branch is main, and you like whenever you commit it, all the changes goes to the main branch. Okay, now let us assume a scenario in a production project. What happens is, developers pushes changes to the main branch. Like if you talk about the branches, initially you will have the default main branch. Okay, now everyone developer all developers pushes changes to the main branch, and the QA team tests the changes, and then after the complete integration testing, they will push the changes of main branch to the production, and it will work complete. Like production, in the production you will have this, whatever the code you have in the main branch, that will be present. Now after the sprint is over, each developer, like you have developer D1, developer D2, and there are multiple developers, right? Let's say you have some D1 D2 developers, D1 D2 D3. Now what, like let us assume you have a single branch and everyone is working on that branch. Now D1 is assigned one feature, and D2 is assigned one feature, and D3 is assigned one feature. When you, like when all people are working on this project, on this main branch itself, now since the testing is not completed, that all the features that are getting worked upon by D1, D2 and D3 are in initial phase, and some or the other thing keeps breaking, right? Like if developer D1, he pushes some change, and it is not like he pushes some changes to the main branch, and there are lot many issues because of his change. Now D2 and D3 are also blocked because they are trying to run something using the code that is present in main, and they are also pushing their code to test their code. Because of D1 changes, they are also getting blocked. Okay, so this way what happens is, like each developer, because of changes of one person, yeah, other people are also getting blocked, because while test, like while making the changes, initially you will not be able to test it completely when your code is in the initial phase. Okay, so in this case, instead of having the instead of having a single branch, if each developer has, like if each developer creates their own branches from main branch, like putting keeping taking main as a difference, if a developer D1 creates branch B1, and if the developer D2 works on branch B2, and developer D3 works on branch B3, then they are able to work individually without blocking others. Like even if the branch 1 has some issue, only D1 gets blocked, and because of the changes of D1, other people, be like the developer 2 and developer 3, are not getting blocked, and they are able to work individually. That is one of the like advantage of creating branches. And one more thing is, and mostly in software projects, how it works is, whatever code that is present in the main branch, or whatever branch you suppose, like could be in few like in few projects it could be develop branch as well, in few projects it would be main. So you consider the code present in this branch as a stable one. No one should make changes to this main branch or develop branch without any proper testing. So let's say if someone comes and asks, if some other team or some other person comes and asks you to give me the stable code, you point out to your main branch, because that is the production ready code and that is properly tested code. And if other people want to test or try out the things, they create their own branches. Okay. And one more thing is, let's say like you have this main branch. Okay. Now a developer d1, like developer b1 works on the like he creates branch b1 and he works on it. Now what happens is, could be a issue got raised in production which is very important and it has to be fixed immediately. So in that case, what you can do is you can create another branch. Like if the developer d1 doesn't create a b1 branch and if he works on the main branch, his code is not properly tested, right? Let us assume a situation where you don't have multiple branches and developer d1 is working on main branch only. Like you production release had happened and developer d1 working on main branch like on main branch only. Now his code is not properly tested. Like it has to be tested by the vendors and the QA team, and the integration testing has to be done. Now an issue suddenly got raised in production, you have to fix it. Now if I make changes to this branch and push the changes present in this branch, definitely it will break in production, because along with the code that is present already in the production, you are like along with the code present in the production, you are pushing the fix for the issue in the production. Along with the developer d1 has made changes for his feature which is not tested. So if you have a single branch, if some production issue rises, then it's difficult to fix. Like if you, let's suppose you have a branching strategy and developer d1 creates a branch b1 from main branch and he is working on b1. Now suddenly an issue raises in production, and if you create a branch called hotfix from main branch, and if your code is properly tested, you can merge your changes to the main branch from hotfix branch. So in this way, even if production issue rises, you can handle it independently without any issues. So these are the several advantages of having branches. Okay. Yeah. And yeah, how to create a branch is like you understood right here. uh, Whenever you make a change, a commit object is created, and each commit will gets pointed to the previous commit. Now like my main branch is this. Okay, let us assume my main branch is this. I have all these three commits. Now I have to create one branch. Now to create a branch, whatever the changes that are present in main should also be present in my b1 branch as well, because I am creating branch by taking main reference as a main branch. With like by default the branch that gets created is main, and whatever branches that gets created later on should have some reference, be it main or branch or be it some other branch. Okay. Now let us like I am considering this main branch as the reference and I am creating the b1. So my b1 should have the same changes or the same commit history as main. So what I can do is my b1, instead of copying all these commits again to branch b1, I can just create a pointer. I can create a branch b1 pointing to this commit. Okay. So pointing to this commit. So when I create a new branch, I just need to create a pointer to the latest commit of the branch from which I am creating. This is so simple, right? Like you need not copy everything that is present on the main branch to your new branch. Main branch already has the commits and you just create a pointer that is pointing to the latest commit of the main branch. That's it, branch gets created. This is very important feature of the Git. Like if you consider other version control systems, it takes almost hell lot of time to create a branch, because how their branching system works is they copy everything that is present on main branch to the branch b1, which takes lot of time. Like if your branch is having so many changes, and copying it takes a lot of time, and every time a developer creates a branch, it consumes almost lot of time. But in Git, it is so simple. Like you just create a pointer and point it to the latest commit of the branch. That's it. Your branch gets created. This is so simple, right? Yeah. Now if you see, like by default, let us assume you have this master branch. Okay, this is the master, this is the default branch. Now this is the default branch. Initially when you created one commit, your master branch would have been pointing to this commit. And later on when your commit is created, like when a new commit gets created, your master branch will point to this commit. And when you add a new commit, your master branch will point to new commit. So this is how branching works. Like this head and like head, you know, right? Head is the pointer. Like you will have multiple branches in a project, like master branch, B branch, C branch, kind of thing. And currently I am on which branch, I need to know, right? I am on which branch. Or if I want to switch to branch C, my head will point to C. So head represents the current branch. Okay, so here my head is pointing to master branch. So my master branch is, it's just a branch, is nothing but a pointer to the latest snapshot or latest commit. So here you have this master branch and it is pointing to the latest commit. And if you want to get the history of this branch, what you will do, you have to, you know, for each commit you have the parent, right, which represents the previous commit. You have to traverse through the commits and get the changes. This is very simple in Git, creating the branches. Now you have initially a single branch. Now I create a new branch called testing. Okay, now since I am creating a new branch, as I said, it's just creating a pointer. Okay, now my master is pointing to this one, and even my testing is also pointing to this commit. So this is so simple. Just create a pointer and assign it. Now both my master and testing are pointing to a same commit. Okay, now if you go here, what happens is, like I have created a new branch testing. Okay, but I'm like, as soon as you create a branch, you don't move on to that branch. Like let's say I'm on master branch, and then I created a branch testing by taking reference as a master. Now a testing branch gets created, but your head will still point to master. You have to manually switch to the testing branch. Now here what happens is, initially I created a branch testing, and then I switched manually to my testing branch. Now my head points to testing branch. So your head represents what is the current branch a person or developer is working on. Now what I'll do is, I here F30AB. Now initially both my master branch and testing branch are pointing to this commit. Now I created a new branch testing, and then I moved to my testing branch. I have created a new commit on testing branch. So what happens, master will still point to this commit, and testing branch, it gets a new commit gets created, but it points to this commit. Okay, now I created a new commit. When you create a new commit, what happens? My branch will move to the latest commit, and even my head will be pointing to my testing branch. And this commit, parents is this one, parent is this one. It will have the history of the previous commits, right? Yeah. Now what happens is, now you have committed something onto testing branch. Okay, now that is done. Now if I want to switch over to the master branch, like I'll explain the commands also. Like this is just a theoretical example. I'll create a new project and I'll commit it and I'll show you how it works actually. But here, like, this is just a theoretical example. Now I made a commit to a testing branch, and then I want to move again to master branch. Then using git switch command, I can move back to master branch, and then if I move back to master branch, head also moves to master branch, because head represents the current branch which I am working on. Okay. Now after that, what happens is, here my testing commit is 87AB2. Okay, my testing is this one. My testing branch is moving to this commit. Now I move to master branch, right? I created another commit on master branch. Now my master branch, what happens? It will create a new commit. It will have parent as this one, and my head is also pointing to this commit. So what happened is, when master was here, testing branch created, and like when master was here, testing branch here, testing branch got created, and a new commit got pushed to testing. Now another commit got pushed to master, but test now there is no reference to testing and master. Like from this commit, it got diverged. Like testing branch works got diverged and the master's branch work got diverged till till the point where the branch got created. Only these commits would belongs to testing branch, and further on these commits doesn't belong to testing branch. The work got diverged actually. Okay, yeah, so you understood how to create the branch and how it works in terms of commits, right? Let me like create a new project and show you how this works. Okay, yeah, so I'm creating a new repository. I'll create a new directory, version control system, and I'll move to this directory. I don't have any files. First, since this is a folder, I'll initialize it. ls. Let us suppose I'll create two new text files here. So what I'm doing is I'm creating a new file. Yeah, this is my version control system. I'm creating version text file. Okay. Now, if I run git commit or git log minus all graph, you don't see anything because there are no commits. If I like what I'll do is if I do git status, there is an untracked file. I'll add it to the staging area. Now, if I do this, it moved to staging area. I'll commit it. Added version text file. Now this is done. Let me see the log now. All graph. So if you see, you have a single commit and your head is pointing to main branch, and your main branch latest commit is this one. You can see the same thing even in this diagram also. Like here you have three commits, that's why your head is pointing to master. Here, like you assume this as a main branch, and here your master will be pointing to the latest snapshot. Let us create two more commits. Okay, I'll create, this is a system text file. Okay, now what I'll do is git status. If I do, it's not, system is not there, I'll commit it. This is my second commit. Added system text file. Now if you run git log all graph, what it will have? Now my main branch is pointing to the latest commit, and if you go if you go traverse via these lines, you will have the previous commit. And this is, since this is the initial commit, you don't have any parent. Okay, I'll create another commit. This is a control text file. So git status, if I do git status, I'll do git add. Now if I run git status again, my changes move to staging area. Let me do commit. Git commit -m added control text file. Okay, let me run git log all graph. If I do this, now my head is pointing to main branch, and my head current latest snapshot or latest commit is this one. And when I traverse via these lines, this is my previous commit, and when I traverse via these lines, this is my previous commit. If you see the diagram which I was explaining you, you have three commits. Okay, and my master or my main branch is pointing to this commit. So here also, if you see this one, my head is pointing to main branch and this commit, and here in this diagram it is pointing to this one, right? So the same thing you can see here as well. It's pointing to this one, it's pointing to this one. You understood it, right? Like how it, the whatever I was explaining the slide, it's the same. Now what I'll do is I'll create a new branch. Currently I'm on which branch. If you type git branch, the star symbol shows you on which branch you are. I'll create a new branch called testing. Okay, now what I'll do is I'll run git log all will show the commit history of every branch that is present. Now if you see, my head is pointing to main and there is a branch testing as well. So this particular commit is the latest commit of both main branch and testing branch, but my head is pointing to main. Here if you see, the same thing, this particular commit is pointing to both master branch and the testing branch, the same thing. This commit is pointing to both main branch and the testing branch. And if you see in the, like if you see in the next slide, my head is pointing to master branch. The same thing you can see here, head is pointing to main branch, and testing branch and main branch has the same commits because I created a new branch using main as a reference, but I did not switch over to the testing branch. Now what I will do is, like this is my head, right? Yeah, what I'll do is I'll switch over to head, the testing branch. So to switch to testing branch, I'll use git switch testing. Okay. Let me run git log all graph. Now if you see, you have the same thing. Okay, commits, like commit history did not change. The only thing that changed is in the first thing head was pointing to main, now head is pointing to testing. Okay, that's what you have done. You have switched over to a new branch. That is the same thing. You can see you have master and the testing pointing to the same commit, but your head is pointing to like your head is pointing to testing branch. Okay, now what I'll do is, I am on testing branch, I'll create a new commit. Okay, now I'm on testing branch, I'll create a new commit. Let me create a new commit. This is a testing text file. So what I'll do is git status. If I run, I'll add it to staging area, I'll commit it, added testing test file. Okay, now if I run git log hyphen hyphen all hyphen hyphen graph, here if you see, what happened was, still this commit, like main branch was pointing to this commit, like only these three commits belongs to main branch, and now your head is pointing to testing and you have additional commit here. The same thing you can see here. Your master was pointing to the previous commit, your like main branch was pointing to the previous commit, and your testing branch is pointing to the new commit. The same thing you can see here, your testing branch is pointing to new commit and your head is also pointing to new commit. Your head is also pointing to new commit. Okay, yeah, the same thing whatever I explained in the PPT, the same thing is happening here. Now what I'll do is, like what I have done, I have made, like I have created a branch testing. I moved to the testing branch, I created a new commit. Now what I'll do is, I'll move to main branch again and I'll create another commit. Now on which branch I'm currently, so I'm on testing branch, I'll move to main branch. Now git branch, when I do, I'm on main branch, I'll create a new file. Okay, this is a main text file. When I run git status, it is showing untracked file. Git add off, when I do, it moved to staging area. Now I'll commit this one. Git commit -1 added main text file. Okay. Now what I'll do is, I'll do git log hyphen hyphen all hyphen hyphen graph. So now what happens is, initially what I have done, I just switched over to master branch. Now my head should be pointing to master branch. Now I have created a new commit. So my master branch should point to new commit and my testing branch should point to the new commits, both individual commits. So if you see here, my main branch, like my head is pointing to main because I'm on main branch. The same thing here, my head is pointing to master. Okay, my head is pointing to main branch. here, like, to understand how to navigate this git log graph, you can refer my git log graph video. Now what is happening is, this is my latest commit. So what would be my previous commit? Just go via these lines, okay, downwards, and this is my previous commit, okay, and go via these lines, this is my previous commit, go via these lines, this is my previous commit. So overall the same thing. Initially you have this commit that exists only on the master branch. Here also this exists only on the main branch, and all these commits are common to both testing branch as well as the main branch, because testing branch commit is latest one is this one, and when you traverse via these lines, what happens is, like, it will reach this commit, it will reach this commit, it will reach this commit. When I was traversing for main branch, this is the commit that is not present on testing, but when you traverse downwards, you have these three commits in common. The same thing here. These two commits are individual to master and testing. So this commit and this commit are present. This is present only on main, this is present only on testing. So likewise, this is present only on master, this is present only on testing, and the remaining three commits are common to both. So here also, if you see, these commits are common to both. Yeah. Yeah, that's it, guys. This is just an introduction of the git branches. In the coming videos, we will understand the merging in the git. Okay, thank you.